The definition of multi-level feedback queue scheduler makes it the most general CPU scheduling algorithm. It can be configured to match specific system and the design. Unfortunately, it also requires some means of selecting value for all the parameters to select the best scheduler. Although a multi-level feedback queue is the most general scheme, it also the most complex one. Now let us suppose that Q1 and 2 follow round robin with time quantum 4 and 8 respectively, and Q3 follow FCFS. When a process starts executing, then it first enter Q1. In Q1, process execute for 4 units, and if it completes in these 4 units, or it gives CPU for input-output operation in these 4 units, then the priority of this process does not change. And if it again comes in the ready queue, then it again starts in execution in Q1. If a process in Q1 does not complete in 4 units, then its priority gets reduced and is shifted to Q2. Above points 2 and 3 are also true for Q2 process, but the time quantum is 8 units. In a general case, if a process does not complete in the time quantum, then it is shifted to the lower priority queue. In the last queue, process is scheduled in FCFS manner. A process in lower priority queue can only execute only when higher priority queues are empty. A process running in the lower priority queue is interrupted by a process arriving in the higher priority queue.
Why do we need multi-level feedback queue scheduling, MFQS? For one, MFQS is much more flexible than multi-level queue scheduling, MQS, because MFQS actually allows the processes to move around the queues. So how are they moving around the queues? This type of scheduling actually mainly runs a process for a time quantum, and after that, it can change the priority of the process if the process is too long. Like imagine there's 3 queues, Q0, Q1, and Q2. So Q0 is allocated 8 milliseconds and Q2 60 milliseconds, the time quantum. So if a process from Q1 is taking more than 8 milliseconds, then the process will be pushed to the tail of Q2. So the interesting thing about this algorithm is that it can learn and predict the process after given some time, and allowing optimization of turnaround time, meaning faster response time. The advantages of using MFQS is that it's more flexible and efficient because the process can be moved around the queues, and if the process is waiting too long, then waiting too long from a low priority queue, then it can be moved into the high priority queue to prevent separation. So with this positive comes the negative, and this disadvantage of the queue is that it is complex and it can lead to CPU overheads from the process moving around.